Hello and welcome, I'm your Code Monkey. In this lecture we're going to create a nice UI visual to display our waiting recipes. Okay, so our delivery manager is already working. We are randomly spawning some random recipes every once in a while. Now instead of looking at the console, let's add a proper UI. So for that, over here in the editor, let's go inside the canvas. And by the way, let's click on the button to unlock the canvas. And this is actually the first time we're using the regular canvas. Quite a while ago we just created it, we didn't really set it up, so let's quickly do that. For the render mode, this one is meant to be a regular UI, so let's leave it on the screen space overlay. Then over here on the canvas scaler, instead of constant pixel size, let's go with scale with screen size. Then for the reference resolution, I like to use 1920 by 1080. And finally, I like to fully match with the height. Basically, this means that objects in the canvas will only be scaled if the height changes. For example, let's add inside just a quick UI image just to test. Let's look in the game view. So there you go, there's the image. Let's just put it on a different color. Okay, so there's the image. And note how if I modify the aspect ratio here, so let's say I put it on 5:4, there you go, the horizontal size of the window changed, but note how the element was not scaled. So I can put it even on free aspect, so really wide and does not change the size. Whereas if I modify this, if I modify the vertical size, the image does indeed get scaled up or down. Personally, I like the setup because it means that I only have to worry about positioning things horizontally. If the vertical part gets changed, everything gets automatically scaled. Okay, so great. So over here, let's go back into Full HD, all right, and let's get rid of the image, all right. Back in the scene view, let's quickly look at the canvas, so we can select the canvas, press the F in order to zoom out, and also we can press the 2D button up here to go into 2D mode. Okay, so here's our nice UI. Now inside the canvas, let's create an empty game object, call it the delivery manager UI. Then in the inspector, let's make it stretch to occupy the whole thing, so let's put 0 on everything. Okay, so this window now occupies the entire screen. Now inside, let's do just like we did a while ago for the plate icons, meaning let's make the template that we can then clone, but let's also put those templates inside of a container. So first of all, let's make the container, so a new empty game object, call it just the container. The reason why I'm going with this approach is because I also want to have other objects outside of here. If you remember how we did with the templates, we can actually go there and see. So let's go inside the prefabs, inside the counters. Actually, it's on the kitchen objects, so let's go inside the plate. Over here for the template, basically we use the plate icons UI, this main canvas as the container. But if you remember how we did that, in order to make sure we didn't end up with duplicate icons, we always destroy the previous one when we spawned a brand new one. So every time we were cycling through the children of this object in order to destroy all of them except the template. So over here we're going to use a container so that we can apply that logic only to the children of the container, and that way we can have other objects outside of the container. For example, outside of here, let's say we want some nice text just saying recipes in waiting. So on the delivery manager, let's make it a child of that one. Let's go into UI and let's make a text Mesh Pro. And this is the first time that we're using Text Mesh Pro, so this window pops out. Let's actually import the Text Mesh Pro essentials. Okay, just let it import. Okay, that's it. We don't need the examples or extras, so let's just close this window. And over here on this window, let's name this the title text. Let's set the text to something like recipes waiting. Let's put it up there on the corner, so let's anchor it on the top left corner. Also for the text, I like to put it on a width and height of 0, but of course that makes the text really vertical. So then down here on the wrapping, let's just disable it. So there you go, looks like that, and let's put it over there on that corner. Now in scene view, we are seeing things different. So if you want to see what this looks like, just go into the game view, and over there, yep, we do see the recipes. Let's just make it in bold. So there you go, just some nice text. Okay, so that's our text, and then for the container, let's make inside the delivery template. So let's create an empty game object. Let's call it the recipe template. And for this one, we're going to want to anchor it to the top left corner. So with the template selected over here in the inspector, let's click, and we want to click up here. However, we also want to set the pivot. So let's make sure to hold down Shift in order to set the pivot over there. Okay, great, that's exactly what we want. So we want the template right on the corner. Then let's give it a size of say 250 by 100, okay? Now inside the template, we just need two things. We want the name of the recipe as well as the list of all the ingredients. Although before that, let's actually make a nice visual for the background. So a new UI image for the background. Let's make this one stretch to occupy the whole thing. Let's put everything on 0. Okay, that's the background. Let's put it on a black with just a little bit lower alpha. Okay, that's good. Then for the name, let's make a text field. So inside the template, let's create another text. Call it the recipe name text. Then over here, let's put it a bit small, so on a font size of maybe just 20, let's put it in bold. And let's also again put the width and height of 0, and over here make sure to disable wrapping. Okay, so that's the text, so we've got it up there. Let's just anchor it to the top left corner. Okay, great. Over here we can change the name to recipe. And then what we need is the icons down here. And for that we're going to do pretty much the exact same thing that we did on plate. But before we do that logic, let's just get this basic setup working. So let's just position everything. So first of all, the container for all the templates. Let's anchor it on the top left corner. And let's push it all the way over there. And for positioning them, let's use this time the vertical layout group. So inside, let's duplicate the template just to be able to see them. Okay, so that's pretty much what we want. We can actually set the width and height both to 0. And let's set the spacing to something like 30. Okay, so that's our basic UI. Now let's make the script to run this. So over here in our scripts, let's create a brand new C# script for the delivery manager UI. Let's go into the parent game object and let's attach the script. Let's open. Okay, so now here, first we need a field for the container and another one for the template. So let's do a serialized field, private transform for the container, and another one for the transform, and this is going to be the recipe template. Then let's do pretty much the same thing we did previously. So first of all, let's actually go on awake in order to hide the template. So game object set active into false. Okay, so first we hide the template. Then let's make an update visual function. So private void update visual. And for updating, we're going to do the exact same thing that we did. So first, let's cycle through the container and destroy everything except for the template. So do a for each transform child in the container. And if the child is the template, if so, then we're going to continue. And if not, we're going to destroy the child game object. Okay, so we have the cleanup. Now all we need is to cycle through all of the waiting recipes. So that means that over here on delivery manager, we need to expose our waiting recipe SO list. So let's go down here, make a function to do that. Public going to return a list of recipe SO, get waiting recipe SO list. And we just return the waiting recipe SO list. Okay, great. So now here on the UI, we can now go into delivery manager, access the static instance in order to get the waiting recipe SO list. So let's cycle through this. So do a for each recipe SO in the waiting recipe SO list. And for each of them, let's instantiate and let's spawn our recipe template, spawn it inside the container. And then we just need to set this to enabled. So let's grab the transform for the recipe transform. We grab this one, grab the game object and set active into true. Okay, so like this, the only thing missing is the text, but that's okay for now. Let's just see where we're going to call this function to update the visuals. And as usual, we want to be smart and write some good clean code. So let's not do the dirty approach of just updating this on every single update. Instead, let's only call this function when something actually changes. So over here on the delivery manager, let's just make some simple events. So public event handler. Let's call on recipe spawned. And another one, call it on recipe completed. And actually, as soon as I add the event handler, which also add using system, now here we have an interesting thing. We've got a nice namespace collision. It's telling us that random is an ambiguous reference between UnityEngine.random and system.random. That is because both these namespaces, UnityEngine and system, both of them have a class named exactly random. So the code here does not know which class we're trying to use. To solve this conflict, we really just need to be more specific. In this case here, we want to use the UnityEngine version, so let's just write the full name, UnityEngine.random. And yep, that works. Okay, so now let's fire off the events. So first of all, the onRecipe spawns over here. When we spawn a recipe, let's invoke this event. So this event_targs.empty. And let's also get rid of the log. We no longer need that. Okay. Now we could also add the waiting recipe on the event targs, but in this case we don't need it. Just firing the event is enough. And then down here, when the player delivers something, if the player delivers the correct recipe, we remove it from the list. And then let's fire off the event. So on recipe completed, let's invoke with this and event_targs.empty. Okay, so we have the event, and down here we also don't need a log. Okay, so that works. And finally, over here on the delivery manager UI, let's just make a private void start. On start, going to delivery manager, access the static instance, and listen to both these events. So the spawned, and let's also listen to the other one. So delivery manager instance on recipe completed. When either of these work, let's just go and update the visual. So just like this. Let's also rename this because again, instance doesn't sound like a very good name. Let's actually rename this to delivery manager And same thing up here. By the way, I'm using the Visual Studio shortcut, Ctrl-RR, in order to rename this to Delivery Manager. And finally, we also need to update the visual on start, just to make sure the previous ones do not show up. Okay, that's it. So like this, it should be working. We should be able to see no visual, and then as more are spawned, we should be able to see each one being spawned until the maximum. So let's see. Just over here in the UI, let's make sure to drag the references, so the container and the template, and let's hit on play. And okay, right away, actually it spawned one recipe, it spawned instantly. Then after 4 seconds, there you go, a second one. And after 4 seconds, we should be able to see, yep, another one. Now 4 more seconds, and we should see the final one. And now, no matter how long we wait, it should no longer spawn anymore. And yep, that works. All right, awesome. So the basic logic is working. Now let's handle the proper logic on the template. For that, like I mentioned previously, one approach would be over here. You could go and do a transform.find, find the actual recipe name text, then get the text mesh component and set it. That would work, but like I mentioned previously, that would be very dirty, not good at all. We should avoid using find at any time, and we should also avoid the individual logic from the total logic. So let's do it properly and make a proper script to handle each spawn template. So let's create a brand new C# script. Call this Delivery Manager Single UI. Single just because it refers to a single recipe. And also right now we already have quite a few UI scripts, so let's organize our project again. So let's organize a new folder for the UI, and inside let's put all of our UI scripts. So Delivery Manager Single, this one, the plate icons, and the progress bar. So let's put all of these nicely organized in the UI folder. Okay, so with the script, let's go into the recipe template and attach the script. Now let's open. And over here, let's begin by adding a field for our text. So a serialized field. And over here, it's also very important. For the text, we are not using the text inside Unity Engine.ui. This is the legacy text. It is not Text Mesh Pro, so this is not what we were using. Instead, we want to use Text Mesh Pro UGUI, which is inside TM Pro. So we need to go up here and add using TM Pro, and now we can use this type. And also make sure you're using Text Mesh Pro UGUI and not Text Mesh Pro. This one also exists, but don't mix these two. These are two very different types. If we go over here in the editor, and if outside the canvas, if I just create a new 3D object, a new text object, if I do that, then if we look over here in the inspector, we see this one is of type Text Mesh Pro. Whereas for the ones that we're using inside the canvas, if we look, this is Text Mesh Pro, it's a UI text. So these are the two different classes within Text Mesh Pro. You have Text Mesh Pro and Text Mesh Pro UGUI. We're working on the UI, so we want this one. Okay, so we named this the recipe name text. Okay, that's it. Over here in the editor, let's drag our reference, all right. So in the script, let's make a function to set the recipe. So a public void, and let's call it set recipe SO. And we're going to receive a recipe SO. Then we just go into the recipe name text and we set the text to recipe SO.recipe name. Okay, so that's pretty much it. Now over here on the UI script, when we instantiate our recipe transform, let's get component of type of our Delivery Manager Single UI and call set recipe SO and pass in the recipe SO. Okay, so let's see if the name shows up. And yep, right away it does show up, so we can see that we generated a cheeseburger recipe and right now a mega burger recipe. Okay, great. So all that's left are the icons down here. So like I said, that is going to be yet another usage of our template pattern. So inside the recipe template, let's create an empty game object, call it the icon container, and then inside that, let's make the template, and template is just going to be an image, so we can just create an image straight away. Call it the ingredient image. Let's scale it with a size of 40 and 40. Let's put an image by default, just like that. And on the icon container, let's put the width of 0, height of 0, and let's put a horizontal layout group. Put it over there on the left side, and we can create a bunch more just to see how it looks. Okay, so that's pretty much it. Now over here on the single script, let's add a serialized field, private transform for the icon container, another one for the icon template. Then we do the same thing as usual. So when we set the recipe SO, let's first of all clean up the container. So let's do a for each transform child in the icon container. And if the child is the template, then we want to continue and ignore it. If not, we want to destroy the child.game object. Okay, so that's a cleanup. And then let's do a for each kitchen object so in the recipe so.kitchen object so list. Cycle through all of this, let's instantiate our icon template. Instantiate it inside the icon container. So this is going to be the transform for the icon transform. Then as usual, we need to go into the game object, set active in order to enable it. And also let's go up here, make a private void awake, and on awake the icon template game object, let's disable it. Okay, we don't want the template to be visible. Okay, so we instantiate the template, we set it as active. Then since this one just has an image, we can just do a get component of type image. That's image, not image conversion. So image, so it's this one, the one inside unityengine.ui. So let's get this image and let's modify the sprite and set it to this kitchen object so.sprite. Okay, so that's it, that should do it. Let's test. Over here in the editor, let's just go into the template. Let's drag the container reference and the template reference. And let's also rename this instead of ingredient image, put icon template just to be a bit more clear. And we can get rid of the other ones or leave them, doesn't really matter. Okay, great. So let's hit on play and see. And yep, right away it does work. So we can see a burger is composed of a burger and a bun. A salad, yep, there you go, some sliced cabbage and sliced tomatoes. Then cheeseburger, same thing as the burger with some cheese. And then another burger, let's just deliver until we see the mega burger. So let's deliver a cheeseburger, let's cut it. Get this, get some bread, place it in there, pick it up before it burns. That's a cheeseburger, so that one should vanish. And if there you go, it does vanish. Let's see if something else, not a cheeseburger, so let's keep doing until we get the mega burger just to see that everything works. So let's deliver a regular burger. Okay, now let's deliver a regular salad. Okay, just pick up like that, and drop it. Okay, let's see. And yep, there it is, the mega burger. Alright, great. So the visual logic is fully working and the delivery logic, all of it is working. So I can deliver the right recipes and get rid of them from the recipe waiting list, and more are spawned every time. Here we can see the name of the recipe as well as all of the nice icons. Okay, so with all of this, our game is really taking shape. Everything is very close to being done. One massive thing we're still missing is an obvious one, which is sound. So let's do that in the next lecture. Hey again, quick intermission. You're almost at the end, so once again, congrats for making it this far. This is the second secret callout. Go ahead, post in the comments a timestamp and a nice monkey emoji. It will be fun to see how many people make it to this point. By now you already know about the website. I hope it's been very useful to you. And you already know to ask any questions in the comments if you need help with anything. So all that's left for me to say right now is thanks for watching the course so far, and I really hope you've already learned a ton. There's only a bunch more lectures until we get to the final polished game, so let's continue on the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to add some audio to our game, starting with a really nice music track. Okay, so our game is already looking pretty good, but everything is still way too silent, so let's begin by adding some music. Adding this is actually extremely easy to do. In the included assets over here inside the sounds, we've got a really nice music track. I hired the musician to make this, it sounds really good. It's a seamless loop, so to add to our game it's going to be super simple. We just want a constant, never-ending loop. So let's begin by creating an empty game object, call it the music manager. Let's reset the transform, keep things organized, and let's add a component, and we want the component an audio source. Here it is, this one. Like the name implies, this one acts like a source of audio. You will note how by default on the main camera, down here, it already has an audio listener. So the source plays some sound and the listener listens to it. Now over here, we just need to set these fields. So for example, on the audio clip, let's make sure to drag the music audio clip. Okay, great. Next over here, let's enable play on awake. We want it to start playing right away. And for this track, we do want to enable looping. Okay, great. Then for priority, basically Unity has a limit to how many sounds can be played at once. If you play too many, then some sounds won't play. And which ones do play is all based on priority. We always want the music to play, so let's put this one on max priority. Then for the volume, later on we're going to make a proper option screen to handle this. But for now, let's put it on something like 0.4 or 0.5, just to make a nice background track. Then we have here the spatial blend. For this music track, we want it to play the same regardless of where the camera is. So let's make this all the way fully a 2D sound. Okay, and that's it. We don't need to play around with any of the other settings. And just like this, if we are on play, and yep, there's the music. Now, if you're not hearing anything, make sure that on the game view, first of all, that the game is actually selected. Make sure the scene is in focus. So over here I can move around, so the game is in focus. Then on the game view over here on the top right corner, make sure this sound icon is toggled. If not, then everything is muted. And also, again, make sure, like I mentioned on the main camera, that it has the audio listener component. With all of that, yep, you should be able to hear the music. Now this song is playing and it will loop forever, just like we wanted. Personally, I really like how it sounds. I'm really happy with what the composer made. It perfectly matches the vibe of the game. So it really is this simple to add some music to the game. Let me just point out one thing also related to sound. One of the things you can make is an audio mixer. So for example, on the project files, let's create a brand new, and let's find over here the audio mixer. So there you go, here is an audio mixer, then you can double click to open up the audio mixer window. And then over here you have the master node, and then you can create multiple groups. So let's create a brand new group for something else. And then you can play around over here with the effects, with the volume, all kinds of things, all kinds of effects, everything. Then for each sound where you have the audio source, over here note how you have an output. And for this output, you can set it to play on the master, so it plays on everything, or set it on just one individual group. So with this, you could assign a group to one individual type of sound effect, or the music, or so on. Maybe you could even have your music split into multiple stems. So there's lots you can do, but for me, I'm not an audio engineer. Audio is probably the part of game development that I know least about. I just stick with the absolute basics. But if you want to learn more, definitely look into the audio mixer. This is an extremely powerful tool. But like I said, for me, I don't know how to work with it, so I'm just going to stick with the basics. So on the output, let's revert back into none, close the audio mixer, and get rid of this. And there it is, the music is playing, and it all sounds really nice. Alright, so here we very easily added some music to our game. This lecture is actually super short because it is genuinely that simple. Now the next thing that we need is going to be a little bit more complex, and that is adding sound effects. So let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to add some sound effects for our game. Okay, so previously we already added some really nice music, now let's add a whole bunch of sound effects. In the project files, if we go inside the assets over here, we've got all kinds of sound effects. Basically, I hired a really nice sound designer to make all of these, and I think they all sound really great, so let's add them to our game. Now, when it comes to sound effects, there are two main ways to play a sound. One is just like we did for the music, so we can create a game object, add the audio source component and play it. That's one approach, but that basically requires pre-preparing the sound objects. So there is another simpler way that just requires one line of code. So let's begin by making a sound manager game object, so a new empty game object for the sound manager. Let's reset the transform. Now let's make our script, so let's go in the scripts folder, create a brand new C# script for the sound manager. Let's attach the script and open. Okay, so now here let's make a function to play simple sound. So let's do a private void, just call it play sound. And over here the way we play sound through code is actually super simple. We just go inside the audio source class. And in here there's a static function, play clip at point. This, as you can see, takes an audio clip, a vector3 for the position, and finally a volume. So basically it will play that sound on that position. By default, Unity already has 3D sound, so if you play the sound on the left or the right side of the camera, it will play in the correct place. Also for the volume, the further away it is from the camera, the lower it will be. And if we don't want the 3D sound, we can just play directly on top of the camera position. Okay, so in this function, let's receive our arguments. So for the audio clip, it's going to be our audio clip. Then let's receive vector3 for the position. And let's also receive an optional one for the volume. Let's just default this to 1f. Okay, so here we just pass this into our function, so the position and the volume. Okay, great. So now let's call this nice function. And for example, let's start with a simple one. So let's start with the delivery sounds. So over here on the delivery manager script, down here we have the logic for delivering a recipe. And over here we know when we completed a successful recipe or when we failed and the player delivered a wrong recipe. So this is where we want to play some sounds. And again, here we have yet another very important clean code question. We could technically call the play sound function directly from here. That would work, but of course that would make this class tightly coupled with the sound manager. For a simple game on this scale, that approach can work, just play sounds directly from the logic code. However, again, to make things properly, we should really separate the logic from the sound, just like we separated the logic from the visuals. So instead, let's not call the sound directly from here. Instead, let's make two more events. So let's make one on recipe success, and another one on recipe failed. Okay, so now let's fire off these events. So over here we have the success, so on recipe success. And if we get down here, then we have a fail. So on recipe failed. Okay, great, we have 2 events. Now back here on the sound manager, we can just listen to those. So let's do a start, go into the delivery manager, access the instance, and listen to the on success and on failed events. So listen to that one, delivery manager, instance, on recipe failed. Listen to both of these. Again, let's write some good clean code. So let's rename this one instead of instance. Let's put it delivery manager. And same thing on this one. Also name it correctly, delivery manager. Okay, great. So now when you have this, we want to call play sound. And now I want to pass in a reference to the recipe failed sound. So technically one approach would be up here to add a serialized field for an audio clip. That would work. But since we've already done that so many times in this course, here let's use a different approach that I also like to use. Let's create a scriptable object to hold a reference to all of our sounds. So similar to how we define the scriptable object to hold all of our recipes. Let's just comment this out just to make sure the code compiles. Okay, great. So back here in the editor, let's make a new scriptable object type. So let's create a brand new C# script for the audio clip refs scriptable object. Now here, let's make this a simple scriptable object with a create asset menu. Okay, so now for the fields, if we look in the S over here, the audio designer that I hired actually made several variations for each sound. So we've got multiple chops, multiple delivery fails, and so on. So back in the code here, instead of storing a reference for a single audio clip, let's store an array for all of them. So we have the chop, then we have all the others, so let's just add all of the references. So there's a chop, there's the delivery fail, then we have delivery success, then we have footsteps, then the object drop, then the object pickup, then we have the stove sizzle, although this one is just one, then we have the trash, and finally we have the warning. Alright, so these are all of the sound references we're going to use. Back in the editor, let's just create the object. So on the scriptable objects, let's create a brand new one. Let's make it of audio clip refs SO. Just name it audio clip refs SO. And over here, let's just drag the references. So let's use that quick Unity tip in order to unlock the inspector. Now I can select all the chops and drag them. All delivery fails, drag them. Delivery success, drag it. Then for all of the footsteps, after that are all of the object drops. Then the pickups, then we have the sizzle, which is just one. Finally, we have the trash and the warning. Okay, those are all the references. So our scriptable object now has all of the data we need. Let's unlock the inspector, okay. And back in the code here on the sound manager, let's make another version of this function. So let's make one play sound, except instead of receiving an audio clip, it receives an array of audio clips. Then basically we just call the other function. So we call the other play sound function and pass in an audio clip from this array. So let's actually rename this, so audio clip array. And let's pass in an audio clip from here. So do a simple random.range between 0 and the array.length. Pass in the position and the volume. Okay, so just like this, now all we need is a reference to our scriptable object. So a serialized field, private, of the audio clip refs SO. Okay, we have this. Then here in the editor, let's just assign the reference, so the audio clip refs. Okay, great. And over here, when we have the recipe failed, let's go into the audio clip refs. And let's pick up, this one is delivery fail. And then the other one is going to be delivery success. For the position, let's just default to the camera.main transform.position. So like this, the sounds will play exactly on top of the camera. Okay, so let's test and see if it all works. Okay, so here we are, and let's do a wrong delivery. Now, quick warning if you're following along, or if you're just watching the video, this sound will probably be way too loud, but let's test. So if I just pick up the plate and I just deliver an empty plate, yep, there you go, there's the sound. And now if I deliver a correct one, so someone wants a salad, so let's cut a nice salad, chop that, chop this, pick up the plate, pick up that one and that one, deliver the correct salad, and yep, there you go, it does work. Alright, great. So the sound effects work, they played perfectly, but they're a bit too loud. Basically that's because these sounds were designed to be played in the world rather than on top of the camera. So when we play the sound, let's actually play it on the position of the delivery counter. Here is the delivery counter script. And based on our design, we're only going to have a single delivery counter, so we can just make this a singleton. So as usual, public static of type delivery counter, call it instance, with a public get and a private set. Then on private void awake, let's just set the instance equals this. Okay, so now over here on the sound manager, we can just grab delivery counter, and we just go into delivery counter and grab the static instance. And then for the sound position, we can just go into delivery counter, access the transform.position. Okay, so just like this on that one and on this one. Okay, so let's test. Now it shouldn't be as loud. Okay, so here we are, and let's do a wrong delivery. And yep, it does work. Now let's do a successful delivery, so let's make a nice cheeseburger. So grab some cheese, slice it, grab a plate, just need some bread, and deliver it. And yep, there you go, it worked. Alright, awesome. Okay, so this is really it. This is how we're going to play our simple sounds. Now there are some that are going to require more logic, like the footstep sounds and the stove sizzle. But first, let's begin by adding the simple ones. So let's begin with the chop sounds. This is super simple. We just need to go over here onto the cutting counter, and actually we already have the onCut event that we made previously. This was used to spawn the visual, so we can also use it to spawn the sounds. However, there's actually one difference. We're going to have multiple cutting counters, and this one, as you can see, this one is not a static event, meaning each different counter is going to have each list of listeners, and we really don't want to have to subscribe to every single one of the counters individually. So what we can do is, instead of making it a regular event that belongs to each instance of a cutting counter, we can make a static event which will belong to the entire class. But we still want to leave this one just for the visual, so let's do another one, a public static event handler, and let's call it on any cut. Basically, for any static events that belong to any object type, I like to add the keyword any. We're going to fire this event when any cutting counter is going to trigger a cut action. So where we fire this event is exactly the same thing. So over here we've got the onCut, let's do the exact same thing. So on any cut with this, an event args.empty. Okay, so we have our nice static event. Now over here on the sound manager, let's listen to it. So let's go into the cutting counter. Again, we're going to access through the class name, and let's listen to the on any cut event. And over here, let's just play the sound. So let's play the sound. Let's go inside the audio clip refsso, and let's grab the chop sound. Then for the position, we want to know who fired this event, and by following the C# standard, over here we already have the object sender. So we know this was the object that fired this event, and we know this is going to be of type cutting counter, so we can just get cutting counter, and we just grab the sender as a cutting counter. Okay, so we have this, and then over here, very simple, access transform.position. Okay, that's it, great. That will play the cutting sound on that position on that cutting counter. Okay, great. Now let's handle the player picking up something, and for that let's go over here onto the player class, and the way we set up the kitchen object parent system is actually already perfect for this. Down here we have a function, so if we scroll down, yep, this function, set kitchen object. This one is called whenever the player receives a kitchen object, which means really when the player picks up something. So if this kitchen object is not null, then that means the player picked up something, so let's do that. So up here let's make the event. So a public event handler, call it on picked something. And then down here just do a test, so if the kitchen object is not null, so if the player did pick up something, then let's just fire off this event. So just do our usual invoke with this and event args.empty. Okay, so that's great. Then on the sound manager, let's just listen to it. So let's go into the player class, let's access the static instance, and let's listen to the on picked up something event. And again, let's rename this to a proper name, so player on picked something. And over here, let's just play the sound. And for the sound, go into the refs and grab, in this case, the object pickup. And for the position, let's just go player.instance and grab the transform.position. Okay, that's it. Next for item dropping. Now we can only drop items on a counter. So over here we have the base counter class, and again we have the same thing, so we have the set kitchen object. And again the same thing as with the cutting counter. We don't want to be required to listen to every single counter, we just want to listen to one event, so let's make it up here. So a public static event of type event handler, and let's name it on any object placed here. And then down here, when we have the set kitchen object, we do the usual if kitchen object is not null. If so, then let's fire off this event. Okay, great. And on the sound manager, let's listen. So go into the base counter on any object placed here. When that happens, play the sound. Then let's go into the audio clip refs. And this one is the object drop, so that one. And for the position, let's do the same thing we did. So we cast the base counter equals the sender as a base counter. And then we go into the base counter and let's grab the transform.position. Okay, so we just need one more special counter type. Here we have the trash counter. And this one, it never really changes the parent, it just destroys the object. So over here on the trash counter itself, let's fire off an event. But again, let's make it static, even though we're only going to have one trash, but make it static just to be able to support multiple. So public static event handler on any object trashed. And then over here, just fire off this event. So invoke with this and event_ars.empty, okay. So now if we go into the sound manager, and over here, once again, the trash counter on any, not the on any object placed, but on any object trashed. And on this one, let's do pretty much exactly the same thing. So let's copy this. The sound is going to be the trash sound. Instead of a base counter, we could just cast it to a base counter, but let's make it proper. So let's make a trash counter as a trash counter, and this is a trash counter. Okay, great, that's it. So these are all of our basic simple sounds. As you can see, all the logic is super simple. So let's test and see if it all works. Okay, so first of all, let's pick up an object. So if I go into a container and I pick it up, and if there you go, there's the sound. Now if I drop it somewhere, and if there's the sound. Now for the trash, pick it up, drop it on the trash, and if there's the trash sound. Okay, great. Then also let's check out the cutting. So if I pick up some cheese, drop it there, and cut, and if there you go, got a really nice cutting sound. Okay, so far so good. Now let's handle the more complex ones, starting off with the stove. For this one, the sound is meant to be looping, but only when the stove is on, so we don't want to just play once, but play and stop playing depending on the state of the stove. So for this one, instead of spawning the sound through code, let's actually spawn it on the object itself. So let's go inside the stove object, let's go on the stove counter and open up the prefab. And inside this prefab, let's create a brand new empty game object, name it sound. Let's reset transform, make sure it's on 0, 0, 0. Okay, great. Now let's add an audio source component. And for the audio clip, let's use the pan sizzle. Let's make sure to not toggle play on awake, but we do want it to loop. And let's also make it a 3D sound. Okay, so that's the basic setup. Now to control this, let's make a script. So let's go into our scripts folder and let's create a brand new C# script. Call it the stove counter sound. Let's attach the script over here and let's open it. So now here first let's grab the audio source component. So we've got a private audio source for the audio source and just go on awake and audio source equals get component of type audio source. Okay. Then we're also going to need a reference to the stove counter. So let's add up here a serialized field, private of type stove counter for the stove counter. Then back in the editor, let's drag that reference. All right. Now on the stove counter, over here we already have the states and we have the onState change event. Again, the same one that we used to modify the visual. So on the sound, let's do pretty much exactly the same thing. Over here, let's do a private void start. And on start, let's go into the stove counter and listen to the onState changed event. And basically, when this changes, we want to check if it's frying or fried. If so, then we want to play the sound. If no, then we don't want to play it. So let's define a bool, call it play sound. And we're going to play if the state equals we are frying or the state equals that it is currently fried and about to burn. Okay, then if we have a play sound, then let's go into the audio source and call play. And if not, then let's go into audio source and call pause. Alright, so that's it, pretty simple. Let's just make sure to save our prefab, go back outside and let's start on play. And okay, for stars, there's no sound playing. Now if I pick up some meat and I drop it on there, and if there you go, there's the sizzling sound and continues going, and now it is still sizzling, but if it burns, it should stop. So if I go, And if there you go, the sizzling sound stopped. Alright, awesome. So let's take this one out. Let's actually trash it. Now let's pick up another one, let it cook. And once it's cooked, pick it up, and there you go, the sound does stop. Alright, awesome. So we just have one more final sound remaining, that's the footsteps. By the way, the warning sound, this is going to be added during the polished lecture. For the footsteps, we want very much the same thing that we did on the stove. So we're going to want a script to handle that logic. But this time we don't need an audio source on the player, we're going to use the same play method as the other ones. Let's just make a script to run the sounds, so let's make a new C# script. For the player sounds, let's go into the player game object and attach the sound, okay. So now here let's first grab the player reference. So private player, and on private void awake, let's get the component of type player and assign it to the player, okay. Then for the footsteps, basically we want to play them every certain amount of time. So let's do up here a private float for the footstep timer, another one for the footstep timer max, and let's say we want to play, say, 10 times per second. Then we do a basic update, and on update, footstep timer, countdown by time.time, and if the footstep timer is under 0, then let's reset it, so set it to the maximum, and it's in here that we're going to play the sound. So now here we have two options. We can fire an event here, and we can listen to it on the sound manager, so exactly the same thing that we've been doing previously. Or we can just trigger the sound directly from here. Doing that will mean that this class is tightly coupled with the sound manager. Usually we want to avoid tight couplings. However, in this case, the player sounds class, this one is really only meant to exist alongside the sound manager. So in this case, it's perfectly fine to tightly couple them. So let's play the sound directly from here, which means we need a reference to the sound manager. We could make a serialized field or just make this a singleton, so let's do that. So a public static type sound manager, name it instance with a public get and a private set. Then on private void awake, we just set the instance equals this, okay? So then over here we can just access it. So just go into the sound manager, access the instance, and we call play sound, which we actually need to make public. However, this function also takes a reference to the audio clip array. So that means we need a reference to the audio clips. So again, we have multiple options. We could add over here on the player sounds, add a serialized field for the footstep sounds, or we can just make a specialized function over here on the sound manager. Both options can work just fine. Let's go with the second one just to be different. So just make here a public void play footstep sound. We're just going to receive a vector 3 for the position, and then we just call play sound. Let's go into the audio clip refsso, and let's pick up the footsteps and play it on this position, and let's also receive the volume. Just up here a float for the volume. Okay, so that's great. Now we just need to call this function. So over here on the player, instead of calling play sound, let's call the other one play the footstep sound. Then for the position, that's the player transform.position. And for the volume, I just exposed the volume just in case you want to make the footsteps a bit more silent or not. But for now, let's begin with 1F and then see if that's way too loud. As usual, instead of using magic numbers, let's define a float for the volume, put it at 1F, and over here use the volume. Okay, great. However, you might be noticing an obvious issue here. Right now, this is going to play non-stop. Obviously, we don't want to do that. We only want to play footstep sounds if the player is actually moving. So this is pretty simple. We just need to ask the player if it is moving. And we already did that, so player is walking. So if the player is walking, then we play the sounds. If not, we don't. Okay, that's it, so let's test. So here we are, and if I'm standing still, there's no footsteps. Okay, that's great. And as soon as I move, yep, there you go, we got some nice footstep sounds. Alright, great. So with all of that, we added all of our sounds. Now here, note how we mostly use this method of going into the audio source and using the play clip at point function. This one is great because it is so simple, but it does have limitations, specifically with regards to all of the options. If we look on the audio source component, here we have all these options, so you can use an output, use an audio mixer like we saw in the previous lecture. We can play around priority, play around the pitch, make it 2D or 3D, play around over here with how the sound falls off. So tons and tons of options that you can't really access if you use that simple function. So one approach, if you needed these options, you could make each sound a prefab, so make a prefab for each different audio clip, and then instead of calling that function, you would simply instantiate that prefab to spawn that audio. So you've got lots of options depending on how complex you want your sound to be. But for a simple game and for simple sounds, this one line of code is super simple. Alright, so here we have added sound effects to our game. That coupled with the music that we had previously already makes everything sound so much more alive. It's really starting to look like a proper game. The one thing we still don't have is some kind of game start and game end scenario, so let's add that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, let's add a simple beginning state to our game. So right now we can play the game. All of the mechanics, everything works perfectly, it's all been implemented. However, in the beginning of the game, it just starts right away as it loads. There's no start, no countdown, no time for the player to get ready. So let's sort that out with a simple countdown. Let's begin by making a general game manager script to handle all of our general game states. So let's create a brand new C# script. And now here you could use the name Game Manager, so you could use this name. However, for some reason, Unity likes to add this custom icon when a script is named exactly Game Manager. Personally, I don't like this. I don't want it to be a different icon. I want this script to look and behave just like any other one of my scripts. So personally, I don't like this, but if it doesn't bother you, then go ahead, use it. Doesn't really change anything, just a visual. But in my case, I prefer to give it a different name, so sometimes I call it Game Handler, or other times just something related to this game, like for example the Kitchen Game Manager. And just like that, it won't have that custom icon. Just need to go inside and rename this to Kitchen Game Manager. Okay, save the script. And alright, now let's make a game object to run it. So a new game object with the same name. Let's attach the Kitchen Game Manager and reset transform. Okay, let's open. Now here we're going to define all of the various game states that our game can be in. So for that, let's define an enum. So a simple enum, call it state. And for the various states, let's say we are first of all waiting to start. Then we are on countdown to start. Then the game is playing, and then we have a game over. Okay, so these are our states. Let's do a private void awake, and on awake let's set the state, so we need to store a state for our state. And on awake we set the state equals, and let's begin on waiting to start. By the way, the point with this waiting to start state will also be very important in the next video covering multiplayer. Basically, we're going to wait until everyone is connected before we start the actual countdown. But over here for now, we're just going to wait a little bit on the waiting to start. Then we're going to trigger the countdown, and then after some time, trigger the game playing state. So pretty much all of these states are going to be time-based. So let's make a simple timer. So a private float for the waiting to start timer. Let's begin on something like 1F. So we just wait for 1 second. Then let's make a private void update. And let's make a state machine just like we've done previously. So do a switch on our state. In case we are on state.waiting to start. If so, then let's go into the waiting to start timer, count it down by time.delta_time. Then if the waiting to start timer, if it is under 0. If so, then let's move into the state, equal state dot, let's go into the countdown to start. Okay, so that's it, and the other states are going to be pretty much exactly the same, so let's just copy this. So we have the waiting to start, then the countdown to start, then we have the game playing, and finally we have the game over, and that one doesn't have anything, so just like this. Like I said, we could reuse the same timer, but let's write our code nice and proper, so let's make different timers for each. So let's make 3 timers. So we're going to have the countdown to start timer. So countdown. For this one, let's default into 3, so we're going to wait 3 seconds before we start. And then the game playing timer. And for this one, let's put it something short, just for testing, so let's put it just test. And then down here, let's just use them. So on the countdown, let's count down this timer. On the game playing, count down this timer. When the countdown ends, we go into game playing. And when the game playing ends, we go into game over. Alright, so that's our super basic state machine. Just a bunch of timers, super simple. Let's do a quick log just to see. So over here, just a debug.log. And let's just print out the current state. Okay, so just like this, let's test. And yep, right away we are waiting to start. After 1 second, going to countdown. Then after 3 seconds, going to game playing. And now if we wait for 10 seconds, after 10 seconds, we should be able to see just a little bit. And yep, there you go, we've got our game over. Okay, great. All the logic is working. Although we actually didn't change anything. Technically, the game right now is on a game over, but everything still works the same as previously, so I can still play, I can still do everything. So let's sort that. When we are in any state other than the game playing state, we don't want the player to be able to interact with anything. We want to leave it movement, because that's usually nice and fun, but we don't want it to be able to interact, pick up objects, or do anything, so let's do that. Basically over here on the game manager, let's just expose a function. So public bool, let's call this is game playing. Then over here, pretty simple, just return if the state equals state.gameplaying. That's it. So now we can go into the player script. So over here on the player script, let's go down into the interaction function. So over here we've got the interact alternate and the interact. And on both of these, basically let's just ask if the game is in the game playing state. If so, we want to interact, but if not, then we don't want to do anything. So to access the game manager, we could add a peer serialized field, or as usual, let's just make a nice singleton. So peer public static of type kitchen game manager, the instance, make a public get and a private set. Then down here on awake, let's set the instance equals this, okay? So now over here on the player, let's just go into the kitchen game manager, access the instance and test is game playing. And we're going to do an if the game is not playing. So if we are not playing, we want to stop this, so let's just do a return. So if the game is not playing, the code is going to stop executing here, and same thing on the interaction. So just like that, we won't be able to interact with anything once we are not in the game playing state. Okay, so here we are, waiting to start. Nope, I cannot pick up anything. Countdown to start. Nope, I can't. And as soon as we go into game playing, yep, now I can't interact, so I can cut a bunch of things. And as soon as it goes into game over state, there you go, currently in game over state. So now if I try to interact, nope, can't do it. Okay, awesome. Everything works perfectly. So in terms of logic, this is really it. There's nothing else we need to do. But of course, right now the player would have no clue as to why sometimes they can grab and sometimes they can't, so let's add a proper visual. First, let's add a visual to the starting countdown. So let's do that as a canvas element. So let's go inside our canvas, create an empty game object, name this the game start countdown UI. Let's press F to focus on the object, press 2 to turn this into 2D. Okay, so let's see. Now over here, we really just need a text object, so let's leave this one anchored on the center. Let's put the width and height both on 0, we don't need that. And then let's go inside, create a new text object, call this the countdown text. And then inside, let's just put a number, so just a 3. Let's put the width and height both on 0. Then down here, let's put it in bold on a really big font size, so let's say something like 250, okay, really nice big number. Then let's also put it centered and down the middle. Okay, that's great, we've got our nice big countdown number. Also, by the way, when using Text Mesh Pro, we can easily add a whole bunch of effects. If we look down here, we have the default Text Mesh Pro material, and over here we can add an outline, an underlay, and so on. So that's really great. However, there's one very crucial thing. When you want to add some effects, always remember that the effects are being applied to the material, meaning any text objects that are sharing this material, all of them will modify. So for the most part, usually you don't want to modify the default material. If you do, then everything using this default material will change. Like for example, I want to add a nice thick outline to this one, but over here I've got some regular text that is also using the default material. So if I now add an outline, and I increase the thickness, and if there you go, those also got an outline as well as this. And if I want to downlay and make it quite a lot bigger, there you go, all of them modify, because all of them are sharing the same material. So usually you don't want to modify the default material. If you want to add some kind of special effects, always make sure to create a brand new material beforehand. So over here, let's remove the outline, put it back on the dilation, and let's go up here to create the brand new material. First, we need to find our font. So over here on the font asset, we can just click on it, and we can see it over here highlighted on the project window. So it's inside the Text Mesh Pro folder, the resources, fonts, and so on. So here is the default font, and inside this one is the font that we're using. Now in this font, there's a nice little arrow icon, and inside we can see the default material. So let's duplicate this material. Although it's important, make sure you duplicate the material and not the font. So with this material selected, I'm going to press Ctrl D, and there you go, it duplicates the material. And over here, let's give it some name. So let's say this is the material that I want to use for the start countdown. So there you go, just like this. Also, one very important thing, the name of the material needs to include the font name, otherwise it won't show up. For example, if I get rid of this, the Liberation Sans SDF, if I name the material just like this, and now I'll look over here on the countdown text, look on Text Mesh Pro, here is the drop-down menu for selecting the material, and over here note how that one does not show up. So it is extremely important, in order for it to show up in here, it needs to have the same starting name. So over here, if I rename this material, put Liberation Sans SDF and then the name, and now back in here, now look, and yep, now I do see my material. Okay, so that's great. And now over here we can add what kind of effects we want, and it will only affect this one and not any others. Okay, so for this one, let's add a nice outline and let's make some nice thick numbers. So over here on the dilation, let's dilate by quite a little bit. Then for the outline color, let's put it maybe on a blue. something a bit like this. Okay, let's push it back just a little bit. Okay, I think that looks pretty good. Now, if you want, you could add even more effects to this. I made another video covering how to use custom textures in your font. Doing that, you can just import the font directly into Photoshop and edit it with all kinds of effects. For example, that method is exactly what I used in my game Hyper Knight to make the hit counter look really nice. I also have a tutorial specifically on that. So if you want even more custom text, definitely go ahead and watch those videos. But anyways, here we have our countdown text looking pretty nice. Now the number itself will be written through code, so let's do that. Let's go into our scripts, into our UI folder, create a brand new C# script for the game start countdown UI. Okay, let's select the parent object and attach the script. Now here, first thing we need is a reference to that text object. So let's add a serialized field, private. And again, remember what I mentioned a couple of lectures ago with regards to the types. So we want Text Mesh Pro UGUI, we want this one. So it's going to be our countdown text. And now for updating this text, basically we just need to know the game state, so we need to know when the countdown should show up. And as usual, let's use some nice events. So over here on the Kitchen Game Manager, let's fire an event whenever the state changes. So a public event handler. Let's call it on state changed. Okay, just like this, no need for the arguments. So let's go down here, whenever the state changes, let's just invoke this event. So invoke this event args.empty. So we change in there, and change down there. Okay, that's it. So now over here on the game start countdown, let's do a private void start. And on start, let's go into the Kitchen Game Manager, access the instance, listen to the on state changed event. As usual, write some nice clean code, so let's rename this to the Kitchen Game Manager. So when the state changes, we basically want to show this if we are on the countdown to start. So let's go here to the Kitchen Game Manager and let's make another function. So public bool is countdown to start active. And we just return if the state equals the state dot countdown to start. Okay, so that's a nice simple function. And on the UI script, if the Kitchen Game Manager, if this one dot is countdown to start active, if so, then let's show, if not, then let's hide. So else, let's do a hide. So let's make these functions, so private void show, and a private void hide. And on this, let's just do the usual thing, so game object set active into true, or over here set it into false. And on start, right after we subscribe to the event, let's also hide it by default. Okay, so that's the basic logic for showing or hiding it. And now for the timer text, technically over here, whilst inside the countdown to start, we could fire an event on every single update. That would work, but it would have some unnecessary overhead. So instead, another option is just make a function to expose it. So let's go here, make a public, return a float, get the countdown to start timer. And we just return the countdown to start timer, very simple. So then over here on the UI script, we can just make a regular private void update. And on update, go into the countdown text in order to set the text. And let's go into the Kitchen Game Manager and let's get the countdown to start timer and just do a toString. Okay, so that's it, super simple. So on update, we're going to constantly update the timer. So let's see if this works. Back here in the editor, let's just make sure to drag the countdown text reference and let's hit on play. And okay, waiting to start, and after a bit, yep, there you go, there's the number, it's currently on countdown, and now the game is playing. So the show and hide did work, although the numbers seemed quite a bit odd. That's because over here on the settings, we have wrapping enabled, so let's just quickly disable this, and let's test again. So there we are, waiting to start, and there you go, there's our countdown, 3, 2, 1, 0, and there you go, game playing. Okay, so it did work. Now of course, as it comes to the visuals, it depends on what you want. For example, if you want to limit the decimals, you can use over here the toString. This one can include all kinds of string formats. For example, for displaying just 2 decimal places, you can add the string format f2. Let's see what this looks like. Waiting for the countdown, and there you go. Now it does show with 2 decimals. Okay, so this is one approach. Alternatively, another format you can use is number sign, point, number. And let's see this one. And yep, there you go, now it looks like this. So as you can see, there's lots of things you can play around with when it comes to the toString formats. But in our case, I don't really want any decimals, I really just want to see whole numbers. So for that, let's just seal out this number. So a mathf.seal, let's seal this one out, and then just do a toString. Okay, let's see. So wait a bit, and we got 3, 2, and 1, and there you go, the game is playing. Alright, awesome! So here we have our waiting to start and the countdown to start. All of that logic is working perfectly. Now the next thing we need is to handle the game end, so let's do that in the next lecture.